Alright guys, we're back here and the next question is asking you to find the each limit. So we're back to solving limits and they're going to be a little more complex. That's why I was really happy to do this exam number 2 because there was a little bit more complexity in it. So don't forget we're doing limits, so don't think about product rule now, don't start thinking about that stuff. So the limit here is that x approaches infinity of x cubed e to the negative x squared. So what would you do here? We're gonna have to, we see right here that obviously this can go in the denominator, right? So if we can rewrite this, x cubed over e to the x squared. Now we still don't know what to do, right? Because if we plug infinity, we don't know what it means, right? So we have to apply something called L'Hopital's rule. This means that we take the derivative of the numerator, we keep on taking the derivative of the numerator and the denominator until we can get something that we can plug in our infinity and it means something, right? So let's go ahead and do that. Limit as x approaches infinity. So we take the numerator, would be 3x squared. Denominator, so we take the derivative of the exponent and then rewrite the original. We see that this can cancel with this, so we take the derivative once more, we'll get 3 over 4x e to the x squared. Limit, of course, as x goes to infinity. We can actually plug in infinity now. It would go in here and it would go in there. And we would get 3 over a really big number. So then our limit is 0. Alright, question B. Let me change color for your eyes. Limit as x approaches 0. 1 minus x squared. Alright guys. This is complicated. Really complicated problem, but we'll get through it. You have no idea where to start, would you? Because if you plug in 0, you have the exponent itself is 1 over 0. What the hell does that mean, really? We actually have to do introduce a variable L to this, L, and that will equal the above. So we're kind of finding the real limit. The true limit is the limit of that. But we're introducing this constant, it's not a constant, this variable, because we can now apply, because usually I was going to say we're going to apply a logarithmic differentiation here, but that's usually when we have an equation in the form of like this, you know, but we don't have two sides of the equation, it's only one-sided. So now we made it two-sided. Now we can apply a logarithmic differentiation. I know math is really surprising. It's like, what the hell? Why did you do that? Who thought of that? So the ln over here would go in front of the limit, because we can't ln a limit, the word limit, it's weird, right? So now we have it in the form that we can work with. So let's keep on going. I can bring this to the front, so let me rewrite everything here. Ln L x plus 0, 1 over x squared, ln 1 minus x squared. Okay, this one is just there, but whatever. Now we can apply L'Hopital's rule to continue with this. L'Hopital's rule would be derivative of the numerator and the denominator until it makes sense. So let's go ahead and the numerator's derivative of ln is 1 over whatever is inside multiplied by the derivative of the inside, so negative 2x, and all over the x squared that we have. The x squared becomes 2x, and we can rewrite this as negative 2x over 2x, 1 minus x squared. So we can cancel this 2x out, and we get negative, well, let me write it here properly, because we have to still include the limit, and negative 1 over 1 minus x squared. And that's for that. And if we actually plug in 0 here, we can actually get a real value. So we'll get negative 1, right? So, and let's not forget this is on the left side always. So the ln L is equal to negative 1. Now we can solve for the real limit of this by just Euler's constant here to the on both sides. So e to the ln L is equal to e to the negative 1. When you use the exponential function and on the ln, they both cancel out, so you're just left with the exponent there. L is equal to e to the negative 1 is equal to 1 by e. Yeah, I know it's not that easy, this problem, guys, but if you now that you know that if you come across something similar to that, you know what to do. It's a bit long, but L'Hopital's rule. I mean, it's common sense. If they give you limits in the beginning of the exam, and they're pretty easy, and then they suddenly introduce limits later on, obviously they're going to be touching on the new concept of L'Hopital's rule. So, common sense too. Alright, let's go to the next problem. Alright guys, now we're moving on to the integrals part of the exam. It's the last little part of the exam where they touch on integrals. So, this one is a word problem about integrals. The velocity of particles of a particle in meters a second is given by the function v of t. So velocity is a function of time sine t minus 4 root t. Find the position function at st if s of 0 is 10 meters. Alright guys, so general knowledge that if you have a function of a particle, we'll call it s, particle as a function of time is equal to some numbers or variables. If you take the derivative of this function, you get the velocity function at the particle at time t. If you further take the derivative, you get the acceleration of the particle at time t. So we're at velocity, and we got to go backwards to position. So that's taking the integral to go back. So we got to take the integral of sine t minus 4 root t. So how would we go about doing that? Let's start with sine. So our function that we're going to get is, now we're applying the integral. So integral of sine t is negative cos t. That's just basic in the tables or knowledge. And this one can be rewritten into exponential form. And then we can apply the integral. So the integral of, let's say, x to something. So you would add 1 to the exponent and divide by that new exponent. So the integral would be x3 over 3, right? So same thing with here. So we have minus. So add 1 to the exponent, that makes 3 over 2. And so 4t3 by 2 all over the new exponent, 3 by 2. So that leads to s of t is equal to negative cosine t minus 8t3 squared over 3. And then don't forget to add that constant, because it's an indefinite integral, but we're actually going to calculate that constant because we are given that the position of the particle at time 0 is 10 meters. So they're giving us the point 0, 10 to plug into here. So s of 0 is equal to negative cosine of 0 minus 8, 0 to the power of 3 by 2 over 3 plus c, and that is equal to 10. So if we solve, cos of 0 is -1. So hold on 1 second. Yeah, so -1 plus c, because this goes to 0, is equal to 10, and therefore c is equal to 11. And so that means that the final function as a position as a function of time would be, so you will rewrite this one here, this function here, with the new constant that we just solved for. Plus 11. That is the answer. Pretty easy, guys. Takes a bit of physics this time, but whatever. Alright guys, we arrived at the last couple of questions, and they're asking us to solve a few integrals. It's the last part of the introductory calculus course where they ask you to do a few integrals. Just to get you warmed up for the advanced calculus where we're doing integrals only. So let's start with question 13. It's 1 plus x squared over dy dx is equal to 2y. The idea is for separable equations, you have to separate the x's and the y's, so you bring all the x's on one side and all the y's on the other side. So if I were to multiply this dx to the other side, multiply both sides by dx, you would have 2y dx, and I just divide both sides by 1 plus x squared, you would get dy is equal to 2y dx, and we'll say times 1 over 1 plus x squared. And now you just got to bring the y's to the other side, so you divide both sides by 2y, you'll get 1 over 2y dy, and I'll rearrange this, dx, and I can bring this 2, multiply this 2 to the other side, so I'll get 1 over y dy is equal to 2 over 1 plus x squared dx. And now I can take the integral of both sides because everything is all on one side. So if I go like this, and I can bring the 2 out to the front here, and then we can do the integrals, and we see that this one is ln of y. This is in the tables, most basic integral, because the derivative of ln is 1 over y. So, but we always have to put an absolute value sign here. It's just the way it is. And the integral of this is in the tables as well. If you bring the 2 to the front, you have 1 over 1 plus x squared, and that is simply arc tan of x. So we have the 2 multiplied by arc tan of x. And we can add the constant on either side, it doesn't matter, but we'll add it here. And that is the answer to our separable differential equation. Alright, the next one is a little tricky. I'll just rewrite it over here. So question B is they're asking you to take the integral of x cubed plus 6x squared minus 4 to the power of 8 multiplied by 6x squared plus 24x du. I mean, it's not that obvious. That's not du, by the way, that's dx. It's not that obvious what to do, but when you see something like this complicated stuff, it's usually going to take a substitution to solve this. So if we put a substitution for the more complicated one here is, so we call u is equal to x cubed plus 6x squared minus 4, and then if we take the derivative, we get 3x squared plus 12x and dx. That's the way that's what you get. And if you notice, this here is just twice this, right? So if I can try to replace all this by du, I would be able to take the integral, because this is now called u, right? We established that that was u. So let's say I multiply both sides by 2, I would get 6x squared plus 24x dx. So now I can actually rewrite this whole integral as the integral of u and 2 to u. And this has a power of 8. So I can bring out the 2 to the front. And then we have a simple integral where you just add 1 to the exponent and divide by the new exponent. 2 by 9 u9, and then you add your constant. Then you plug back in your u, which you had before. So x cubed plus 6x squared minus 4 to the power of 9 all over 9 plus c. Alright, so the last one is also a bit tricky, but this one here, but we'll get through it together. Let me go here and rewrite it. So it's asking for the integral of 5 cosine of ln x over 3x dx. So again, we're going to use substitution again, where we're going to make the complicated part, just call it u. So that will be in this bracket the ln x. Let's say we call u is equal to ln x. We take the derivative, we will get 1 over x dx. And you could see that we have an x in the denominator here, so we can probably replace, put this in that equation somewhere. So let's say I bring the 5 over 3 outside the integral as a property of integrals. I'll have exactly this, u over x dx, which is basically the same as, exactly the same as writing cos of u times 1 over x dx. And we have the 1 over x dx right here. So if I plug all that in, I got 5/3 integral cosine u du, and integral of cosine is the most basic integral in the tables, so it would be 5 over 3 sine u plus the constant. So you put back in the what we called u, sine of ln x plus c. Alright, so that's the end of the exam, the second exam. Again, I wish you guys all the best luck. If you have to go over these problems again, go over them. You'll get it, and you'll be able to spot things really easy. You'll do just fine. So when you're ready to take the second calculus course, I'm going to already have exams ready for you to start practicing with. So I'm going to put them out very soon. In the meanwhile, just please support me by subscribing to me. The bottom right of the screen, you can click the subscribe button and support me, and share the video, because I really want people to see and learn from me. I love helping people, so I'll see you guys in the next video, and good luck.